The DRlearn team offer education and training in the world of heat pump technology and other energy efficiency areas. Professionals from the industry interact and educate participants looking to learn more about the design, operation, and maintenance behind residential and commercial heat pump water heater systems. The educators and designers on the Learn team offer an extensive catalog of courses and trainings for live instruction or self-paced online learning. Enjoy a portion of one of the live training seminars in this video and contact the Learn team to discover opportunities to train and educate your team and customers.
So we'll continue moving forward. Next up, we've got heat pump components. We're going to touch on some of the components of heat pump systems a little bit more in depth, so that way you can understand what these components are and where your troubleshooting issues may lie when you have issues within your system. So what's inside of a heat pump system? Inside of a heat pump system, we will find an indoor coil, we'll find a compressor, we'll find an outdoor coil, we'll find expansion valves, we'll find a control board, and we'll also find reversing valves. Now, the compressor, we'll just talk about that really quickly. That is the most vital component of a heat pump. It's responsible for circulating the refrigerant throughout the system, and it compresses the refrigerant gas, and it also raises the temperature and pressure, enabling the efficiency of heat transfer. Your evaporator coil, this is located indoors, typically, of the unit system of the heat pump, and this facilitates the heat exchange process by absorbing the heat from the indoor air or surrounding environment. As the refrigerant evaporates in that coil, it extracts the heat, and that heat is then carried to other parts of the system. Your condenser coil is very important. The condenser coil is located in the outdoor unit of the heat pump. It plays a crucial role in the heat exchange process. During the cooling mode, the condenser coil releases heat absorbed from the indoor space to the outdoor environment. In heating mode, it absorbs the heat from the outdoor air or ground and transfers that heat to the indoor space, so that heat energy is transferred to where it's needed. Our expansion valve is a small device that's located between the evaporator and condenser coils. Its primary function is to regulate the flow and pressure of the refrigerant. So all your expansion valve is responsible for is regulating flow and pressure of the medium used inside of that heat pump system. So whatever refrigerant you're using, your expansion valve is going to control the flow of that refrigerant. By reducing the pressure of the refrigerant, remember, the expansion valve enables it to evaporate and absorb heat efficiently in the evaporator coil. So I'm going to make sure that expansion valve is operating correctly, or you'll have issues with your evaporation process at your evaporator. Reversing valve is very big when talking about HVAC applications. It is a key component in heat pump systems that provide both heating and cooling functions. It allows the refrigerant flow to be reversed. We touched on that briefly, but this is what the reversing valve does. It basically changes the heat transfer direction between the indoor and outdoor coils. Very important components when talking about the reversing valve. Focus on your indoor and your outdoor coil. All your reversing valve does is it changes what function your indoor coil and outdoor coil serves. When you have a reversing valve in the mix, you will usually be able to reverse the functions of those coils. And what I mean by that is during the heat mode, the reversing valve directs the refrigerant to absorb heat from the outdoor environment, and it releases that heat indoors. In the cooling mode, it reverses the process, which extracts heat from the indoor space instead of outside, and it releases that heat from the indoor space outdoors. So it's just a reversed process. You'll also find inside of your heat pump systems a control board, and the control board in a heat pump system is responsible for coordinating and controlling the system's operation, monitoring any type of sensors you may have embedded in that system, the sequencing component actions, it detects errors, and it ensures system protection as far as faults are concerned. It serves as the brain of the heat pump system, enabling its safe, efficient, and the safe and efficient operation of the entire system. So think of I know when I went through tech school for AC school, I was taught that the compressor was the heart of the system. So if the compressor is the heart of the system, then your control board has to be the brains. Okay, so that a lot of the time we find that in heat pump systems, when we have major issues, we typically have them at the control board a lot of the time. Let's jump into some of these components a little bit more in depth. We have a few different types of evaporators here on screen. We've got fin coil, plate shell, your fridge evaporators, and your tube and tube. We'll touch on each one of these briefly because these are the different types of evaporators you will find out there for these different types of systems. Now, fin coil evaporators, which are also known as fin tube evaporators, are widely used in heat pump systems due to their efficiency and their compact design. These types of evaporators consist of a network of copper and aluminum tubes with fins that are attached to them. The fins increase the surface area, enhancing your heat transfer efficiency, which is the most important part. The refrigerant that goes through these fin coil evaporator tubes, they flow through the tubes, absorbing heat from the surrounding air or fluid. Remember, we have the different sources of heat pumps: air, water, and ground source. So if we're talking about air source, as warm air passes over the fin tubes, heat is transferred from the air to the refrigerant inside the tubes. This process facilitates the evaporation of the refrigerant, resulting in cooling or dehumidification of that air source. Now, your fin coil evaporator is versatile. It can be used in various applications, including air conditioning, refrigeration, and heat pump systems. And they offer a large heat transfer area within a very compact space, making them suitable for both residential and your different commercial applications. Next up, we have our plate and shell evaporators. And these are typically used in your geothermal applications, but they are utilized in heat pump systems. These evaporators consist of multiple plates that are stacked together, and it's enclosed in a shell. The plates typically have grooves or channels within them on the surfaces to guide the flow of the refrigerant in that system. The refrigerant enters one side of the plate shell evaporator, and it flows through those grooved channels that are marked inside of each plate. Now, as it passes through the plates, heat is exchanged with the fluid on the other side of the plates, air or water. Those are our sources. And the refrigerant evaporates, which then absorbs heat from the fluid, while the fluid on the other side is cooled. So these types of evaporators are a little bit more complex in design. You'll find them on chiller systems. I hate to say chiller systems when I'm working with a heat pump, but the reason I call them chiller systems is because they look like them, very similar, but they are heat pump systems and heat pump applications. And we'll touch on those a bit later. You'll see an actual example of the type of system that would utilize a plate and frame type of evaporator setup that we can see here. Now, your plate and shell type of evaporators offer high heat transfer efficiency due to their large surface area and turbulent flow created within those grooved channels on each plate. They are often used in applications where precise temperature controlling is required, such as heat pump systems for radiant floor heating, swimming pool heating, or any type of industrial process cooling. Okay, so if we're needing to create something that is manufactured that requires a high level of process cooling, such as the manufacturer of pharmaceuticals, you would probably find that they have a plate and shell, a plate and frame type of evaporator used in their application. And next up, we have our fridge evap, which, as you can see here, it's just used in refrigerator applications. You can see that nice frost buildup on that one. As we just finished talking about the defrost cycle, that will probably end up going through some sort of a defrost cycle at some point or another, depending on the control schedule that is embedded in that system. And then lastly, we have our tube and tube, which is another geothermal application. The tube and tube type of setup is going to be used in geothermal applications, larger systems, and you'll mostly find them, or not even mostly, I will say your tube and tube you will find on your very large industrial or commercial type of applications or systems. Next up, we have our compressors, another major component inside of our heat pump system. I'll go through a few of these different compressors you might find when dealing with heat pump systems. First up, we have our reciprocating compressor, popular choice for heat pump applications, particularly in smaller systems, utilizing a piston cylinder mechanism to compress the refrigerant that flows through it. As the piston moves back and forth, it typically creates a suction and compression stroke, drawing in and compressing that refrigeration gas or that refrigerant gas. Now, reciprocating compressors are known for their efficiency, reliability, and a wide operating range. I love these compressors. I have had to replace a few of them in my career, but not many. And the reasons that I did replace any of these were usually due to warranty or electrical issues at the site where a fault or not a fault, but a voltage spike of some sort caused the system to go bad. Next up, we have scroll compressors, widely used in heat pumps due to their compact size, high efficiency, low noise level. Consists of the scroll compressors typically consist of two spiral-shaped scrolls, one fixed, one orbiting, and interlocking compress the refrigerant. Scroll compressors offer smooth operation, reduce vibrations, and enhance energy efficiency. Next up, we have our rotary compressors, or the compressors, another type commonly used in heat pump applications. It employs a rotating mechanism with vanes or blades to compress the refrigerant. As the rotator spins, the gas is drawn into the compression chamber, compressed and discharged. These types of compressors are known for their quiet operation, compact size, and ability to handle a varying load or varying loads efficiently. Following our scroll, we have our screw compressors. These types are usually used in large heat pump systems, consist of two helical rollers, male and female, meshed together and rotate to compress the refrigerant. So we're always looking to compress the refrigerant and increase the pressures and temperature of that refrigerant inside of the compressor. Now, in a screw compressor, as the rotator turns, the gas is trapped, progressively compressed along with the length of the screw. Now, these screw compressors are valued for their high capacity, reliability, and ability to handle high pressure applications. So once again, you'll see this type of system in a more commercial or industrial application. Same as your centrifugal compressors. Centrifugal compressors are typically used in large-scale commercial or industrial heat pump systems. These types of compressors employ a high-speed impeller to accelerate the refrigerant gas and converts its kinetic energies into pressure. Now, centrifugal compressors offer high flow rates, well suited for large capacity systems, and are known for their energy efficiency. Now, your centrifugal compressors, these compressors, I've worked on systems with centrifugal compressors in the past, especially in the Air Force. The government usually uses a lot of these systems. But you'll find that they are used in large, extremely large sites, 50,000 square feet, 100,000 square feet, where you have an enormous amount of cooling responsibility. You'll find these types of systems. Next up, we have expansion valves. And expansion valves are important. We know that expansion valves are what controls the flow of the refrigerant in our system. And here on screen, we have, a few different kinds. So we'll talk about TXVs, EEVs, and also fixed orifice tube or cap tube. Now, your TXVs or thermostatic expansion valves is a type of refrigerant metering device that uses a temperature sensing bulb to regulate the flow of refrigerant in the evaporator. Remember, we're trying to regulate the flow of that refrigerant or that medium in the evaporator. Now, the bulb on that TXV is attached to a suction line near the evaporator, and it senses the temperature of the refrigerant leaving the evaporator. As the temperature changes, the valve adjusts the size of the opening to control the flow of refrigerant. So as that valve is controlling the flow of refrigerant, what it's doing is it's preparing the refrigerant to enter the evaporator system, so that way it can evaporate the refrigerant so it can continue on the cycle through the compressor. We also have another type of expansion valve called an electronic expansion valve, which is starting to become used more frequently due to its precise metering of refrigerant. The EEV, or electronic expansion valve, is a type of refrigerant metering device that uses an electronic control module to adjust the opening of the valve. So unlike the TXV, your EEV is using an electronic device in order to open the orifice of the valve so that way it can modulate the flow of refrigerant. Now, that module receives the signal from various sensors in the system, including temperature and pressure sensors, and adjusts the opening of the valve to maintain the desired superheat level. So those of us that are here that have worked around refrigerants and worked around charging systems, you understand what superheat is. That is a topic for an entire 4-hour day. We won't go into it today, but you are able to control your superheat levels with your expansion valve, specifically the electronic expansion valve. And next up, we have our fixed orifice cap tube, simple type of refrigerant metering device that uses a fixed diameter orifice to regulate the flow of refrigerant into the evaporator. Next up, we have a few different types of condenser systems. We've got air-cooled, water-cooled, evaporative, and also shell and tube. Our air-cooled condensers is the most common type of condenser used in heat pump system. It uses ambient air to remove heat from the refrigerant, which is circulated through a series of finned tubes. Here we go again with the finned tubes. Those are back. The air is either forced over the tubes using a fan or pulled or drawn through the tubes by natural convection. Following that is water-cooled condensers. And water-cooled condensers is a type of condenser that uses water to remove the heat from the refrigerant. So the water is circulated through a series of tubes, which are typically made of copper or some other metal. And the refrigerant flows through the tubes, transferring the heat to the water, which is then circulated through a cooling tower or other type of heat exchanger to remove the heat. And I love this way of operation because it's very thorough. You have your water-cooled systems where your condensate goes out to the cooling tower, and it is cooled down at a large water tower outside, which is drawing all the heat load out of that hot water and then recirculating that water back into the system. Very, very interesting process. Following our water cool, we have evaporative. Evaporative condensers is a type of condenser that uses water and air to remove heat from the refrigerant. The water flows through a series of tubes, which are cooled by the water that is sprayed over those tubes. The water then evaporates, carrying heat away from the refrigerant. The air is also used to help evaporate the water and remove heat from the refrigerant. And then lastly, we have our shell and tube, which the shell and tube condensers and water-cooled condensers, they're pretty much, they might look the same, but they're two different types of condensers used in refrigeration and air conditioning systems. Now, what you want to understand is the main difference between the two is the way they transfer heat from the refrigerant to whatever your cooling medium is. So in a shell and tube condenser, the refrigerant flows through a series of tubes that are located inside a larger shell. Water or another fluid is circulated through the shell, removing the heat from the refrigerant. The heat transfer occurs through the walls of the tubes. So that is your shell and tube condenser. In a water-cooled condenser, this type of condenser uses water as the cooling medium. The refrigerant flows through a series of tubes, which are typically made of copper, another metal, and then that water is circulated through a heat exchanger or cooling tower where it absorbs the heat from the refrigerant. and that's done by air within a cooling tower. Next up, we have our PCB, or our control board, which we'll talk about this briefly. It's a very important component and part of the heat pump system. The PCB, or printed circuit board, is a critical component of heat pump systems, which once again, it serves as the brain of the system that controls its operation. Now, this little board here is responsible for receiving input from various sensors and switches throughout the system and using this information to control the various components of that system, such as, remember those major components, your fan, your compressor, and your reversing valve. Now, here's a quick breakdown of those key functions and components of a typical heat pump PCB control board. You have your microprocessor. It's the microprocessor is the main processing unit of the PCB, and it is responsible for executing the control software and making decisions based on input from various sensors and switches. Next, you have your input-output ports. The input-output ports on the PCB board controls are used to connect various sensors and switches throughout the system. So these include temperature sensors, pressure sensors for high pressure, low pressure, flow sensors for water flow, and switches that detect whether doors and windows are open or closed. So different sensors and switches go into your input-output ports of your PCB board. Your power supply. The power supply on the PCB control board is responsible for converting the incoming AC voltage into the appropriate DC voltage required to power the various components of that board. So you'll have your AC and DC operations occurring there on from your power supply, and that is done through the printed control board, where it is able to convert your AC voltage into the required DC voltage for the operation of that board. And then you have your relay switches. These switches on the PCB used to control the operation of your compressor, fan, reversing valve, and other components that's in that system. The switches are typically controlled by the microprocessor, which sends the signal to open or close the switches based on the current operating condition of that system, whether it's in heating or cooling mode. And then lastly, you have your LED indicator, my favorite part, because it tells you what's going on. The LED indicators on the PCB control board provides visual feedback on the current operating state of the system. This can include indicators for factors like your power, is it on, system status, is it running, and any type of error codes, which is one of the reasons I love your LED indicators, is that it uses these lights to provide you with error codes indicating that there's some sort of problem with various components, a sensor, even the PCB board itself. You may see within the literature of that specific system that a red flashing light from your LED indicator means a red flashing light flashing 5 times a second could indicate that your PCB board is bad. So that saves you the time and energy that you would have to put into doing a thorough diagnosis of the system by having you understand that there's an issue utilizing these LED indicators. So the PCB board plays a extremely critical role in the operation of a heat pump system, and it ensures that the system operates efficiently and effectively under a wide range of operations and different conditions. It's a pretty complex component, and you have to have experience dealing with it. It requires specialized knowledge. A lot of the time, an expert to design it, install it, maintain it. And what you just need to know about this specific board is that it is an essential part of any type of modern heat pump system available today. Especially if you're talking about variable speed compressors, more than likely you will see one of these PCBs in that system. Following our following our PCB, I'm going to talk a bit about the reversing valve, and that is it right here. It's this lovely piece of component here. The reversing valve is the part of the system that makes a heat pump a heat pump. the component that separates heat pumps from air conditioners. The valve directs the flow of the hot gas coming off the compressor based on if the space is calling for heating or cooling. Excuse me. When the hot gas comes off the compressor, the valve will either direct the flow to the heat exchanger for cooling mode or to the coil for heating mode, or to the heating coil for, not heating coil, but the condenser coil for cooling mode, for coil for heating mode. The valve body has a slider inside that shifts back and forth, and we'll show what that looks like on the next slide. And this happens on the call for cooling and heating. As shown on this specific graphic, we'll see here shortly, when the system calls for cooling, the slider moves to the left so that the compressor discharges flow to the heat exchanger. When there's a call for heating, there's a little plunger or slider in there that moves to the right, and it directs the flow of the coil. The slider movement reverses the flow through the refrigerant cycle to either remove heat from the room or to add heat depending on the need. So it always goes or boils back down to what mode are you in? Are you in heating mode or are you in cooling mode? And whichever mode you're in, the slider inside of that the solenoid of that valve will slide back and forth in order to direct the movement of that refrigeration. These valves have a huge impact on the operation of a heat pump, and it doesn't affect the refrigeration cycle, but it does affect the operation of it when you're talking about reversing the cycle. So to make it a bit more understandable what's going on here, I think this slide will definitely do numbers. Here we go. So when talking about your three-way valve, okay, it's going to do two things. It's either going to work in heating mode or in cooling mode. So if we take a look over here, we're in cooling mode. Your compressor discharge, okay, you can see where that's coming from the bottom. Here are your sliders. Your sliders are going to be these, they're going to be right in here. You can see the position of your slider underneath the three pieces of pipe that offer the different direction to where your refrigerant is flowing. So if we're in cooling mode, the slider is pulled all the way to the left, okay? So in cooling mode, your compressor discharge, okay, is gonna go to your outdoor unit or your condenser, okay? In heating mode, your compressor discharge is going to go to your indoor coil or your evaporator. So the slider, which is in here, is going to be pulled to the right. Okay, a little complex, but it's something that will allow you to understand a little bit deeper how we're switching from heating to cooling in a system with only using this valve. This valve will allow us to direct our refrigerant where we require it per the mode that we're running. And our modes are always going to be cooling or heating. So before we carry on or move forward, I just want to jump on some of the issues you could have, because you do have issues with these valves. You have some common problems with the reversing valve that's usually these different types of issues will stop your system from working. Sticking or failure to switch modes. So if you have issues with your system stuck in cooling or stuck in heating mode, it could be due to the actual valve failing stuck in that mode. If your valve fails stuck in cooling mode, you won't get any heating from the system. What typically needs to happen when you have a bad valve is you have to contact a qualified electrician to go, or not electrician, but a HVAC technician to go in and literally cut this valve out of the system and replace it with a brand new valve that will allow modulation of this slider in here. So that way you can have your cooling mode and your heating mode. If you have any types of refrigerant leaks or refrigerant that has escaped from the system, this can definitely reduce performance, potentially damaging the compressor and other components. And lastly, electrical failures. If you have any type of electrical issues, like I said earlier, spikes in electricity can damage components. If you have electrical failures or any type of electrical issues, the solenoid can fail and the valve will not be in operation. So we understand that the reversing valve in itself is a critical component of the heat pump system, and it allows the system to switch between its heating and cooling modes. So we want to know and understand that this is a very, very important component in the heat pump system. So we just went over some of the different components in our heat pump system. We touched on the evaporator and what it is. It's a heat exchanger located indoors that absorbs the heat from the indoor air or water. We have our compressor responsible, it's heart of the system, but it's responsible for compressing the refrigerant gas and increasing its temperature and pressures before sending it to the condenser. Our condenser, this is where the heat exchanger located outdoors releases the heat absorbed from the indoor air or water. And then we have our expansion valve, which reduces the pressure and temperature and regulates the flow of refrigerant as it passes through our evaporator. Then we have our control board, the brain of our heat pump system, manages the operations of the heat pump, various components. It regulates the temperature, controls the compressor, and activates our defrost cycle if we require that. And then lastly, we have our reversing valve, which is a key component of the heat pump system that allows it to switch between our heating and cooling modes. Reversing valve, heating and cooling modes. The purpose of the reversing valve is to reverse the flow of refrigerant in the heat pump system, which changes the direction of that heat transfer. So all we're trying to do with a reversing valve is renegotiate the direction of our heat transfer. Either we want to take the heat that we obtained from outside and put it inside, or we're super hot inside and we want to take that heat load and send it outside. Our reversing valve is going to be responsible for that in a heat pump system that provides both heating and cooling.